Let's look at MCA Stability Examinations for Chief Mate, March 2019, question number 2. It says, a vessel is floating upright in salt water and the present particulars are as follows. Forward draft 8.450 meters, aft draft 8.550 meters, kg 7.90 meters. The vessel is to load bunkers, heavy fuel oil, into number 3 dB port and starboard tanks and sail upright with a maximum draft of 8.600 meters. Using the stability data booklet, calculate each of the following. The maximum weight of bunkers to load. Part B, the weight of ballast to transfer between the aft peak and the forepeak so that the vessel sails on an even keel draft. We'll first calculate the arithmetic mean draft for the vessel, which is forward draft plus aft draft divided by 2. When we put in the values for forward draft and aft draft, we'll get 8.450 plus 8.550 divided by 2, which is equals to 8.500 meters. We calculate arithmetic mean draft in order to calculate the LCF or to derive this value of LCF from the hydrostatics so as we can find the true mean draft. The next step, as I said, we calculate arithmetic mean draft to find the LCF. So our next step will be to find the LCF. So LCF at 8.500 meters, which is this, was found out to be 65.950 meters and it has been derived from the hydrostatic data. We will now calculate true mean draft because this is the draft with which we can enter the hydrostatic data and derive the remaining values. So true mean draft is equals to aft draft minus trim multiplied by LCF divided by LBP. We'll put in the values for aft draft, which is 8.550. The trim is 0.100 meters, which is the difference between forward draft and aft draft, multiplied by LCF, which is 65.95, which has come from here, and the LBP, which is 137.5 meters, which are given in the stability data booklet. So we'll come up with the true mean draft equals to 8.502 meters. The question which was asked was how much bunkers we can load. So the limiting draft was given to us as 8.600 meters. So for the displacement of 8.600 meters, we obtain the value of 18359.0 tons, and this has been obtained from the hydrostatic data. And we know that our true mean draft is 8.502 meters, which is 18123.9 tons. So maximum weight of bunkers to load is 235.1 tons, which has been obtained by subtracting this value from this. Sometimes there is a confusion when with this question where they have asked the maximum weight of bunkers to load with a maximum draft of 8.600 meters. Sometimes people think that the maximum draft is the maximum value between the forward draft or aft draft. But here the MCA is stating the maximum draft as true mean draft because there is no way where we can calculate the maximum weight of bunkers to load if we consider the maximum draft of 8.6 either as aft draft or the forward draft. When we look at the B part, the B part states the weight of ballast to transfer between the aft peak and the forepeak so that the vessel sails on the even keel. We had calculated the true mean draft as 8.502 meters, which is this value. So from this value, we entered the hydrostatic data and obtained the following values, which is MCTC initial, which is 206.4, LCB initial, which is equals to 69.359 meters, and LCF initial, which is equals to 65.948 meters. Next, we'll put in the formula of the trim, which is trim is equals to displacement times LCB minus LCG over MCTC. Here we can straight away write it as LCB minus LCG because we know that vessel is trimmed by stern. Because if vessel is trimmed by stern, that means the longitudinal center of buoyancy, which will be somewhere here, and longitudinal center of gravity, if it is somewhere here, force of gravity is going to act downward, force of buoyancy is going to act upward, which will trim the vessel by stern. Since we are using MCTC in the formula, the trim which we put in should be in centimeters. So we put the trim as 10 centimeters. The displacement is 18123.9 tons, which we got here, times the LCB, which is 69.359 meters, which we had derived from the hydrostatic data, minus the LCG initial, which we need to find out, over MCTC, which is 206.4, which has come from this place. When we rearrange the equation, we'll get the value as 10 multiplied by 206.4 divided by 18123.9. So this value has gone in denominator and this value has gone up in numerator. So we'll be left on right hand side of the equation with the values as 69.359 minus the LCG initial. When we solve it further, we get the value as 0.114 when we have solved this value, which is equals to LCG, which is equals to 69.359 minus LCG initial. So LCG initial has been found out as 69.245 meters because in this equation, the LCG has gone on the left hand side and 0.114 has come up on the right hand side. After deriving the LCG initial, we'll make the LCG table, which has the following columns with description, weight in tons, LCG in meters, and longitudinal moments in tons meter. We'll input with the initial values. So initial values for the vessel with the displacement of 18123.9 tons, which was obtained here, and with an initial LCG of 69.245 meters, which has been obtained from here. The bunkers were loaded, which is equals to 235.1 tons. This value has come from part A, final answer, which is this. The LCG of the tanks have been given as 57.870. Since the bunkers are supposed to be loaded in both port and starboard tanks and LCG of both the tanks are same, so we will have just one input, which is equals to 235.1 tons at an LCG of 57.870. We can also do it by splitting the bunkers in port tanks and starboard tanks also, which will also give us the same answer. So we will get the longitudinal moments initial, which will get by multiplying these two values, and we will get the bunkers longitudinal moments, which we get by multiplying these two values. There is nothing to do with the free surface moment in the longitudinal table. So we get the total value for the weight, which is sum of all these two values, as 18359 tons, and while summing up all the longitudinal moments, we'll get the final value as 1268594.7. So LCG final will be equals to sum of all the longitudinal moments divided by sum of all the weights. So sum of all the longitudinal moment is 1268594.7, which has come from here, divided by 18359, which has come from here. This will give us the final LCG value as 69.099 meters. We now know that displacement final is 18359 tons, which is this value. So all the parameters including true main draft, MCTC and LCB will change because the displacement of the vessel has changed. Therefore, the new parameters are true main draft is equals to 8.600 meters, MCTC is equals to 207.7, LCB is equals to 69.310 meters. These values have been derived from the hydrostatic data against the weight of 18359 tons because this was our final weight. We'll again use the trim formula where trim final, F means final, is equals to W times LCB minus LCG divided by MCTC. We have written LCB minus LCG because we can clearly see that LCB is bigger than the LCG. LCB is 69.310 meters and LCG is 69.099 meters. Carry forwarding with the formula, when we put in the values, the weight will be 18359 tons, which we have got here. The LCB value is 69.310 meters, which we have derived from the hydrostatic data, which is here. And LCG is 69.099 meters, which we have derived from the tables, which is here. And MCTC is 207.7, which we have derived from the hydrostatic data and have written here. So trim final will be equals to 18.7 centimeters or 0.187 meters. So in order to bring the vessel upright, it is important to change the trim of the vessel by 18.7 centimeters towards head, which will make the vessel even keel. So we'll write change of trim is equals to trimming moments divided by MCTC. So trimming moments is the weight times distance over MCTC. So weight is unknown and the distance is the LCG of forepeak tank minus LCG of aftpeak tank because this is the case of shifting, divided by MCTC. Since we are using MCTC in the formula, the trim needs to be in centimeters. So change of trim is equals to 18.7 centimeters, which we have got from here. And the LCG of forepeak tank is 130.56 and LCG of aftpeak tank is 3.07 meters, which we have derived from the hydrostatic data. The MCTC is 207.7. When we solve this equation, we'll take 207.7 on the left hand side in the numerator and we'll be left with 3883.99 equals to W times 127.49. 127.49 has been derived by subtracting this value from this. We'll get weight is equals to 30.5 tons. So weight of ballast to transfer between aftpeak and forepeak tank would be equals to 30.5 tons. This will be the answer to part B of this question.